friends, in our last session we have started with our new chapter that was architectural design patterns for cyber manufacturing system and industrial internet of things. In that we have started with CPS based manufacturing and industry 4. Even we have seen the example for a semantic digital object memory as well as orchestration unit. That what is the semantic digital object memory and what is orchestration unit, how they are going to communicate, as well as we have seen that how a workpiece data as well as a drilling tool or a tool data, or we can say machine data, will be stored in a object memory, that is a digital object memory. In today's session we are going to continue with the same topic, and also we are going to understand the integration of a knowledge database and a machine vision. This is Fazan Kagdi and I welcome you all to a lecture series of industrial internet of things. So let's begin and continue. Now, as the name itself suggests, that production floors, which means the floors where a production of a workpiece will take place, where the machines will be present, such as drilling machines, milling machines are present. Different types of machines, number of machines will be present on a production floor, that is in a workshop. Okay. So now we are going to consider a simplified production line, which will be represented by a digital object memory. Okay. Now let us consider that we have a workshop which has two floors. Each floor will have three drills, that is three drilling machines, and another floor will have three milling machines. Okay. Now the transportation between these floors and other relevant destination is considered to be automated. That is, the automatic transmission of a workpiece from one floor to another floor is taken place, that we have assumed. Okay, by automated guided vehicle. Okay. Now clearly you can see that the drills are specified the following instructions in our object memories. Okay, so what are the instructions which are present in a digital object memory for a drilling machine? So see carefully, it is clearly written that drill A can hold even a large workpiece and drills in various depths and sizes, but only up to a certain degree of hardness, which means this data is present in a digital object memory, which defines that drill A, okay, drill A can handle a large size of a workpiece and drill in a various depths and size, but which type of workpiece can be handled? So only which has a certain degree of hardness. Very simple. Now second case, there is a drill B. Drill B has the same ability, and in addition to that, this drill can machine any type of a workpiece of any degree of hardness. Okay, but the condition is that it will consume more power. Okay, the more energy will be consumed compared to drill A. And there is a third drill, that is drill C, which can hold and process three workpieces at a one time, which means three workpieces can be machined simultaneously by using drill C, that is drilling machine C. Simple. Okay, now this is possible only if they do not exceed a certain size and with the same material restrictions as a drill A. Now definitely that it will require a more energy consumption compared to drill A. Why? Because three workpiece will be drilled simultaneously, but definitely we can say that it will require a lower energy consumption, or lower energy will be consumed when each workpiece is machined separately, right? Okay, now next condition, the milling cutter are specified as follows in a digital object memory. So first it is written, mill A can hold even a large workpiece and mill in a various shapes and size, but up to a certain degree of hardness. Similar in case of a drill A. Okay, so mill A can handle large workpiece and mill in a various depths and sizes, but the condition is that up to a limited hardness value of a workpiece. Second, mill B has the same ability as a mill A. Okay, but addition in is what? It can mill any type of workpiece of any degree of hardness. Okay, but it will definitely consume more power compared to milling machine A. And third case, mill C can hold and process three workpieces at the same time simultaneously, but only if they do not exceed a certain size and the same material restriction as a mill A. Obviously, the energy consumption is higher compared to milling machine A, but lower when it is used for milling each workpiece separately. Right. Now let's move further and consider a case, that use case 1. orchestrated production. Now what is an orchestrated production? What is orchestration? Let us understand that. So orchestration is an automated configuration. It is a management and a coordination of a computer systems, applications and services. Okay, that is called an orchestration. Orchestration means in a harmonic way. Okay, we need to follow a step-by-step procedure. Okay, automated configuration should be there, coordination of a computer system, application and services. So this all is called a orchestration, and it helps the IT tools to manage complex tasks and workflows more easily. Okay, now let us assume that a piece of a metal, or we can say a workpiece, arrives in a workshop which demands a drilling operation and let's say two different milling operations. Okay, these are the requirement that these operations has to be performed on a workpiece. Okay, by the customer. Now, what is going to happen? So first of all, we need to verify the properties of that workpiece. Okay, so the properties and the production plans and of an incoming workpiece will be first verified by this service orchestration unit. Okay, it will verify all the properties, and that semantic object memory will then, based on the properties of a workpiece, will define that on which drilling machine, that is whether drilling machine A, drilling machine B, drilling machine C, on which drilling machine the workpiece has to be placed, and on which milling machine the workpiece has to be placed for a gear cutting operation. So that will be done by the semantic object memory. Okay, so its shape and hardness makes it, let's say that it has been defined and determined by the orchestration unit and a semantic object memory, that the workpiece shape and hardness makes it suitable for drilling machine A, so which is issued to perform the operation on that workpiece. Now meanwhile, let's say that another two workpieces are also coming, that is second workpiece and third workpiece are also in line for performing the same drilling and milling operations each. Now let's say the second workpiece is of a harder metal compared to the first workpiece. So definitely that hardness is higher, which means which drilling machine is best. So drilling machine B is best. It will be sent to drilling machine B automatically. Okay. Now the third workpiece could be handled by drilling machine A, but at that moment of time, drilling machine A is performing operation on a workpiece number 1, right? So it will give an indication that a digital object memory will mark it as busy. Drilling machine A is marked as busy. Okay. Now, however, since the instructions are not explicitly ordered, the workpiece can still send to milling machine A. Why? Because it is obvious that since all the drilling machines are busy, definitely we can do a gear cutting operation. At that time, milling machine A will be ideal. So we can send that workpiece directly to the milling machine A, which is ideal. Now once drilling machine A, drilling machine B and milling machine A are finished with their operations, the workpiece can be transported to the next destination. That is a successive operation which has to be performed can be easily done. Okay. Now the second harder metal, that is workpiece, is then further sent to the milling machine B for the further processing of a gear cutting. And a first workpiece and a third workpiece now changes the place. Obviously, that is a task is performed and will leave the production line to the new destination after the operations are finished. So definitely we can say that what is the task of a service orchestration unit and a semantic object memory. So you can clearly see it is written service orchestration unit will check all the incoming workpiece for a specific properties, that is the required properties, what is the hardness and all will be checked by that orchestration unit, and then semantic object memory will make sure that only a suitable workpiece are sent to a machine and that every workpiece is processed as soon as possible. Okay, now let's move on further. So now we need to see our next topic, that is integration of a knowledge database and a machine vision. Now in this topic also we are going to consider a use case. Okay, so there will be three use cases which we are going to use in this topic of integration of a knowledge database and a machine vision. So the use cases which we are going to consider is listed over here. You can clearly see three cases. It can be either an automated basic process in a hazardous surrounding like a load of a petrochemical liquids, okay, in a cylinder or in a container. Then after, one of a several automated processes ongoing parallel in a classical production plant like a assembly process. And third case is an implementation to connect different automated process steps using overall RFID system, that is radio frequency identification system, in a laundry process. Laundry, we know that a dry cleaning process. So in that process, how we can achieve or integrate our knowledge database and a machine vision. Okay, now remember that machine vision, as the name itself suggests, that we are going to provide a vision to a machine to take certain decisions. We have several examples of a machine vision provided to the robots, right? Also, as the name itself suggests, it machine vision. So we have several examples of a machine vision. You would have heard about the system that is a mask detection system, in which a machine is going to see the number of people which are present in a particular area and will detect that which particular person has wear a mask or not. Okay, so it can be easily determined by a machine vision. Okay, that it is going to visualize, it is going to see the persons which are in a surrounding. Similarly, we can take an example of a thermography. Now, what is a thermography technique? So thermography is going to help to determine a temperature of the number of people which are present in a surrounding. So we can say that out of hundreds of people, easily the thermography technique, that is a machine vision technique, will help to determine that which particular person has a higher temperature, right? So it can be easily determined by again, it's an application of a machine vision. Okay, this technique actually of a thermography is used in even a movie that is called a Predator. Okay, now next, a pandemic drone. So pandemic drone, we know all the function of a drone, right? The drone has a cameras, it is going to capture that who is present at which particular location. All the data can be easily captured in a drone. So again, it is a application of what we can say, it is an application of a machine vision. Okay, even to detect an earthquake, that at which particular location an earthquake can take place. So a robot can easily detect by using a several ultrasonic waves and several techniques, and by determining the frequency, right? So again, this is a application of a machine vision, right? So we can say that even in case of a transportation system, machine vision plays an important role, right? That it is going to visualize that number of cars, it is going to see the number of cars which are moving on a road. Whichever car is over speeding, so directly it is going to capture the peak, right, photo of that car along with a number plate. So again, it is an application of a machine vision. So now this machine vision and a knowledge database is applied in our industry. Okay, so you can clearly see that we are going to consider three cases which I have told. Okay, now next we are going to consider see that on which factors the knowledge database is based. So we can say that knowledge database are going to consider the different conditions concerning the use case. Okay, that what are the different conditions about the case which we are going to consider. Then after, their updates and extension possibilities. Okay, second. Then after, third is the number of stored parameters and attached handling routines. Okay, and a fourth is the mode to teach a new items with a different level of human skills. So these are the factors which will be considered by a knowledge database. Okay, now let us move on and see the examples. So now you can clearly see that we are going to consider three examples. Okay, each of these example is going to show that how different conditions can occur while implementing a robot based cyber physical system within a small and medium sized enterprise and within a large enterprise. Okay, that is OEM. Now, first case we are going to consider is of a petrochemical liquids. Okay, so what it is going to say that in a hazardous surroundings, obviously our target is to redesign the plant, right? A large scale plant has to be redesigned. So this is going to make use of a modern technologies. Along with that, we also need to record the existing technologies, and also we need to consider the spatial security requirements in this technique. Okay, which will be suitable for deployment of a technology and a human, which means a deployment of a robot and a human. So these are the factors which are most important while deploying the robots and a humans in a petrochemical industry or petrochemical plant. Okay, now in our chosen example, long cycle times and a low variation are relevant. Okay, that is in a petrochemical liquids, while handling it, obviously the cycle time will be longer and low variations are most relevant. Okay, so we can say that due to, definitely the forces will be much higher. So due to the high forces which will be occurring in the process, an industrial robot has to be a heavyweight robot. Okay, so that robot has to handle a weight up to a 200 kg of that petrochemical liquids. Okay, the interaction of a database now is limited to the internal use of a company and might only be attached to the operational database. Now second example is of a laundry case, that is a laundry industry. So obviously that a research task is going to consider the already existing process which are automated since decades, okay, but we need to focus on redesigning the process which are manual, okay. So the approach is to handle the remaining manual process which will inhibit from increasing the efficiency and a process optimization, okay. So obviously the forces occurring in the laundry industry will definitely will be the lesser. Okay, so lightweight robots are sufficient enough which have to handle a weight up to a 10 kg. Okay, so due to, you can clearly see it is written that due to low occurring forces within the process of handling a laundry pile, a lightweight robot with a load of 10 kg maximum is utilized in a laundry industry. Now, definitely the cycle time will be very fast with a very high number of parts per minute which has to be identified. The interaction of a database is not limited to the internal use of a laundry, and it should be connected to the suppliers, customers and logistics. Now let us see the third example. So in the next slide, you can see now in the third example, which is of an assembly process. Okay, so in this example, we are going to develop a robot-based cyber-physical system within a small and medium-sized enterprise. The task will be handled by the hand of a worker, that is human worker at a current state. Okay, so the focus will be to optimize the assembly process with an additional quality inspection, which should take place at an early point of time in an automated assembly process. So what is a challenge in this? So the special challenge is to we have to implement a lightweight robot in a restricted space, in a very small space due to its working range. Okay. And along with that, it has to handle a lot of components. Okay. So definitely the cycle time will be long cycle time. And a task includes the handling of a large components and movements. So the interaction of a database is now not limited to the internal use of a SME, that is a small and medium sized enterprise, but it should be connected with a supplier as well. Okay guys, so I hope that you are clear with our topic of integration of a knowledge database and a machine vision. In our next session, we will start with our new topic. So till then, stay tuned and thank you all.